Hi there, this is Sean from Maker Wannabe, and welcome to my first video. In this video I'm going to cover the circuit I built to convert AC to DC current using a bridge rectifier. I am using a small stepper motor to power up an LED. After a quick video showing it working, I will give a rundown of what happens when the motor is spun. Here you can see the completed circuit. As I spin the stepper motor with my finger, the current generated is passed through the bridge rectifiers and converted to DC. You may notice that I have no pull-down resistor before my LED. Fortunately, the stepper motor does not generate enough power to blow the LED when I spin it up with my finger. Looking at the wires from the motor, you will see that I have a blue and green wire for each of the coils in the motor. The blue wire is connected to two diodes on opposite sides. One diode's anode is connected to the blue wire and the other diode's cathode is connected to it too. For the green wire from that same coil, this is repeated but to different diodes. The diodes for the blue and green wires connected too, in such a way that the cathodes go together and the anodes go together. I drew red lines on the diagram to show that the current will not be able to flow through the diodes in this direction. Starting on the left with the AC waveform, let's take a look at how the output moves through the diodes. On the first part of the wave, the voltage increases, hits the peak and goes back down again. This flows out of the coil and through the diode whose anode is facing the coil. Remember that the current is blocked by the other diode connected to that coil. Positive voltage flows out of the diode and down into the resistor. As the motor continues turning, the voltage will drop and become negative, as highlighted in red on the left graph. What this means is that the polarity has switched in the coil, so the second set of diodes comes into play. Voltage flows out of the coil at the bottom, through the diode and down again into the resistor. What we end up with is DC current as shown on the right hand side graph. It is important to note that you will have pulses instead of a flat line as per normal DC current. This can be smoothed out using a capacitor, which I will cover in a later video. I hope you enjoyed my video and understand now how a bridge rectifier works. If you enjoyed my video, please like it and look out for more as I bootstrap myself from being a maker wannabe to being a full-on maker.